Hello YouTube, RJ. Well, after our last video where we prototyped out the crystal filter for our radio, I went ahead and did as I said, and I moved all the parts over to another prototype circuit board, and then I prototyped up a 500 Hertz crystal filter for CW. After doing that, which you're looking at here in the top right, what I did then was I sat down in my DipTrace PCB CAD software and I developed a professional built PCB with both sets of crystals. And one thing I did a little different is I used two latching relays to switch between the crystals. Now the benefit of that is with latching relays, when you apply power, they switch and then you don't need to continue to apply power. So they're energy saving for things that are not going to be intermittent, like turned on and turned immediately off, like a PTT. The one benefit is they don't continue to use power. You switch and then leave it. If you want to switch to the other filter, you have to apply power to the other set of coils. The other benefit of that is a lot of people do not realize the small miniature relays that we constantly use in our amateur built radio stuff. If you really read the technical specs, they're not designed for long continuous being turned on. The coil heats up, it causes some different chemicals to vaporize, and eventually it coats the contacts and makes them fail prematurely. So this gets away from it because you only apply current to the coil long enough to switch and then you stop. So that's why I decided to go with those. Really no more expensive than the standard intermittent relays, where it's switched to one set of contacts. When you apply power, it switches to the other as long as you continue to apply power. So that's how I built this board. Other than that, it's basically exactly what we have. And so I'm going to build this board now. I'm going to do a time lapse so you can watch it be built very quickly. And then we're going to do a little testing. We're going to see how our crystal filter is working. Okay, we finished the build and we've got it on the bench to test, and I've got it hooked up to the spectrum analyzer. I've got the tracking generator turned on and it's bringing a signal in on this side and returning it back to the signal generator, the signal spectrum analyzer this way. We've got our 12 volts applied to control the relays and such. I've got a little jumper running off with 12 volts. So we can see that the PCB built versions come out a little bit wider than what I was targeting, 3.1K on 3 dB. That's still fine. It's a little wide, but it's fine. We could tweak with it and probably get it down. The loss is pretty good, 2.99 dBm, so basically 3 dBm loss. Very happy with that. I normalized the spectrum analyzer before I started, so we would get rid of any losses in the cables. So that's what the filter is actually doing for us. So we will make the 3 dB up, of course, from our amplifiers. So basically I've got the SSB and CW input here to trigger, and currently I'm on SSB. I'm going to apply 12 volts to the CW for just a moment while it changes the relay, and we should see it switch. And there it is. Now we've got our 500 Hertz we were looking for CW. Little more loss, tighter filter, more loss. You're down about just shy of 11 dBm. So I've got a lot of makeup for that with amplifier, but that's not horrible for how tight this filter is, 500 Hertz. So as you can see, basically you just apply, if you watch me here, you can see I just apply voltage for just a brief moment to one side or the other, and it switches and stays in that position until I apply power to the other side. So that will allow us from our controls of our radio to choose what filter we want to use, the wider SSB or the narrower CW filter. So that's it. I'm pretty happy with the outcome. Would like to have seen a little less loss on the CW filter, but I think all in all, it's not bad in reality. So we've got our crystal filter done. And just to let y'all in on a point, my intention is, as I'm building and explaining what I'm doing, and I'm building these little board modules, is to make these little boards available for our viewers. What I'm working on right now is getting to the point with, hopefully we get to enough subscriptions on the YouTube channel that I can actually set up a store on YouTube where you can literally click on the videos and purchase these boards. I'll make them very competitive in price. They'll be so much cheaper than you going out and having them made, that way you can afford to follow along at home and build the same item and tweak and improve. And my intent is to get to that point and potentially to have like a spot, a forum or something on the internet. We can talk about what we're finding and work together on things, and y'all can give me input. You can give me input in the comments of the YouTube channel. Feel free to hit me up there if you've got some suggestions, or you see something you say, hey, I don't think that's right. I'm not an expert and I'm open to input. So anyway, this is going to finish up crystal filter series for the radio. So we have a crystal filter. Actually, we have 2 crystal filters. The next thing we'll be doing mixers. We need a couple mixers actually. We're going to need a mixer and a modulator, demodulator. And so we'll be getting into looking at the different types of mixers, building up what we're going to use for the radio in coming videos. So thanks for watching, and I hope to see you in the next video.